Here we are going to work on an example of composite functions. The question says find f of g of x, then g of f of x, and then finally f of g of 2. They've given us two functions, f of x equals x plus 4, and the other one is g of x equals 2x plus 1. So first let's work on the f of g of x. So f of g of x, all right, so there are different ways of writing this. So when we use the circle notation, so f of g of x is the same as saying f of g of x. So what does that mean? That means we input the g of x function, into the f of x function. All right, so it's the same as saying f of, what is the g of x function? It's 2x plus 1. So I'm going to replace the g of x here with 2x plus 1. All right, and then the f of x function is actually x plus 4, correct? It's x plus 4. So I'm going to replace the x in the f of x function with 2x plus 1, this entire expression 2x plus 1. So I'm going to replace the x with 2x plus 1 and rewrite this as 2x plus 1, which is a replacement of x in the f of x equation, and then plus 4, don't forget this, the remaining part of the f of x function, plus 4. And now once we got that, we have to simplify this whole expression. So we get, if I take off the brackets, then it's 2x plus 1 plus 4, and then we see what we can combine here. 2x stays by itself, there's nothing that we can combine it with, so 2x stays as is, but 1 plus 4 is 5, so 2x plus 5 is what we get when we compose f of g of x. All right, so I'm going to write it as f of g. My final answer is f of g of x equals 2x plus 5. So we completed the first part of this question. The next part says g of f of x. So again, now g of f of x, using the circle notation, means we take the f of x function. This time we take the f of x function and make it the input to the g of x function. All right, so that means whatever f of x is, this whole expression x plus 4 is going to be substituted into the x variable in the g of x function. So I'm going to write this, I'm going to replace the f of x with x plus 4, which is the equation of f of x, and then I'm going to substitute into x plus 1. So 2 remains as is. I'm just going to replace this x with x plus 4. So x plus 4 plus 1. And now we simplify this expression. So we have 2x plus 8 after we distribute the 2 to everything, all the terms inside the brackets. So 2 times x is 2x. 2 times 4 is plus 8, and then don't forget the plus 1, all right, plus 1, and then we combine the terms, 2x stays as is, 8 plus 1 is 9, and that's all. All right, so g of f of x is 2x plus 9. So now we completed the second part of it. The third part of it says f of g of 2. All right, so f of g of 2. How do we work on this? Now, f of g of 2, all right, but which expression are we going to use? All right, this is f of x. This is not f of g of x, right? F of x equals x plus 4 is not f of g of x. So it's not correct to plug in 2 into this one. Neither is it correct to plug in 2 into the 2x plus 1 because this is just g of x. We have to plug in the 2 into the f of g function, which is this one, the first one that we worked here. It's 2x plus 5. That's the expression or the equation in which we have to plug in this 2. So you make sure you pick the right composed function. F of g of x is 2x plus 5. So I'm going to take that expression, 2x plus 5, and replace the x, this x, with this 2. So it's going to be 2 times 2 plus 5, which is 2 times 2 is 4, plus 5 is 9. And therefore the final answer for f of g of 2 is 9. All right, so that's how you work through problems of composite functions.